Hello everyone, in today's video, I'm gonna show you how to use the standard normal distribution in calculating probabilities. First, let us talk about the properties of a normal distribution. A normal distribution is a continuous probability distribution for a random variable x. It is the most important continuous probability distribution in statistics. And the graph of a normal distribution is called the normal curve. Now let us take a look further about the normal curve. A normal distribution curve is also called a bell-shaped curve and symmetrical. It is a probability distribution that is symmetric about the mean. And the area under the normal curve is 1 or 100%. Now let us talk about standard normal distribution. So it is also called set distribution, and its mean or mu is equal to 0, and its standard deviation sigma is equal to 1. So from a normal distribution score x, we shall convert it to a standard normal score set. To do it so, we are going to use the formula set is equal to x minus mu over sigma, where x is the observed value and mu is the mean and sigma is the standard deviation. So set score is equal to the number of standard deviations from the mean. And we are going to use this table. So this table is called the set table, wherein we are going to use the less than cumulative frequency, where there is a negative set and a positive set. Now let us have an example. Let us read all together the problem. Scores on an exam are normally distributed with a mean of 65 and a standard deviation of 9. Find the percent of the following scores. A is less than 54, B at least 80, C between 70 and 86. In here, we are going first to solve the percent of the scores less than 54. In doing this so, we are going to determine the probability of x less than 54. Now we have the mean or the mu, which is equal to 65, and the standard deviation sigma, which is equal to 9. And x is equal to 54. Substituting the values in our formula, which is equal to set is equal to x minus mu over sigma, we have 54 minus 65 over 9, which is equal to negative 1.222, and so on and so forth. So in our set table, we only have 2 decimal places. So rounding it up, we have set is equal to negative 1.22. So to find out the value of set is equal to negative 1.22, let us use the negative set table. Then look at the first column, which is equal to negative 1.2, and at the top, which is equal to 0.02. So it corresponds to the value 0.1112. So let us have this normal curve. So in here, it means that the area of this one is equal to 0.1112. Since we are going to find the probability of x, which is less than 54, we are going to find the probability of set less than negative 1.22, which means that it is equal to 0.1112. Since we are going to find the percent, we are going to multiply it by 100%. So the percent of scores less than 54 is equal to 11.12%. So let us have the next one. Let us determine the percent of the scores at least 80. In doing this so, we are going to use x is equal to 80, and we are going to determine the probability of x greater than equal to 80. In a continuous distribution, it is equal to the probability of x greater than 80. So let us concentrate on the probability of x greater than 80. In doing this, so we are going to use the formula set is equal to x minus mu over sigma. Substituting all the values, we get 80 minus 65 over 9, which is equal to 1.666 and so on and so forth. Rounding off to two decimal places, we have 1.67. Now let us take a look at the area of set is equal to 1.67 in the table. So it is equal to, correct, it is equal to 0.9525. So it means that the area of this portion is equal to 0.9525. Now let us analyze how to find the percent of this scores at least 80. So it means that it is the probability of x greater than 80, which is equal to the probability of set greater than 1.67. Because as you can see in the normal curve, we are going to determine the area of the shaded region because it says there greater than 1.67. So in doing this, so we are going to have 1 minus the probability of set greater than 1.67. So in here, we are going to subtract. So 1 minus 0.9525, which is equal to 0.0475. So this shaded area is equal to 0.0475. Since we are going to compute for the percent, times 100%, it is equal to 4.75%. So the scores at least 80 is equal to 4.75%. Let us have the last one. Let us determine the percent of the scores between 70 and 86. In doing this, so we are going to determine the probability of x greater than 70 but less than 86. First, we are going to use x is equal to 70. Substituting all the values, we get 70 minus 65 over 9, which is equal to 0.56. Now let us use x is equal to 86. Substituting all the values, we get 86 minus 65 over 9, which is equal to 2.33. Now let us determine how to get the area between set is equal to 0.56 and set is equal to 2.33. Now let us determine the area that corresponds to set is equal to 2.33 and set is equal to 0.56 in our table. So in determining, so we have set is equal to 2.33 is equal to 0.9901, whereas set is equal to 0.56 is equal to 0.7123. So in here, we are going to determine the area of this shaded region. In doing this, so we are going to compute for the probability of x greater than 70 but less than 86. In doing this, so we have the probability of set greater than 0.56 but less than 2.33. So in here, we are going to subtract the probability of set less than 2.33 minus the probability of set greater than 0.56. Substituting the values, we have 0.9901 minus 0.7123, which is equal to what? Correct, it is equal to 0.2778. So the area of this one is equal to 0.2778. And since we are going to determine the percent, we are going to multiply it to 100%, which is equal to 27.78%. So the percent between 70 and 86 is equal to 27.78%. So in the summary, if we are looking for the less than area, whatever the area in the table, it is the answer. So the answer for this one is 0.9525. But if ever that it is greater than area, we are going to subtract it from 1. And then determining in between, we are going to subtract the area of the larger set value minus the area of the lesser set value. Remember that we only subtract the areas but not the set values. That's it for now. Thank you for watching. Please click the subscribe button below. Bye!